Okay, section 10.7 is about inverses, and you'll be learning this in your math class, but we're going to do a little bit of a very brief pre-teaching for your math class coming up. So inverses are functions that reverse each other. That means if I have an x-coordinate on f of x, then the y-coordinate on the inverse, that would be the y-coordinate on the inverse. And the y-coordinate on f of x would be the x-coordinate on the inverse. So the ordered pairs are swapped around. So I'm going to give you an example of a table. So here's a function, and one way we can define a function is we can define it as a table. So we have x and f of x. So we might have x-coordinates like -2, 0, 2, 4, 6. We might have y-coordinates like 0, 5, 10, 15, and 18. And it looked like it was linear at first, but it doesn't have to be a linear function. It can be any function. But this is a table definition for a function. If I wanted to go from the table definition to a function to the table for the inverse, this is how I would do it. I'd say, well, the inverse is going to be called, and we have a special notation for inverse, which is kind of weird, and I don't love it. For the inverse, we have a little -1 up here, and that says that's not an exponent, even though it looks like an exponent. It says the inverse of x. In order to fill out a table for the inverse, we just have to know that they reverse each other. So in the function, if my input is -2, my output is 0. For the inverse, if the input is 0, the output would be -2. So that means that if I have an input of -2, I put it into my function, I get 0, then I put 0 into the inverse, I reverse myself back to -2. Okay, so if my input in the function is 0, my output is 5, that means if my input for the inverse is 5, my output had better be 0. If my input for the function is 2, my output should be 10. That means if my input for the inverse is 10, my output should be 2. We're always taking the domain of the function, and that becomes the range of the inverse. And the other way around, the range of the function, like 18 is a value in the range of the function, it's in the domain for the inverse. So notice that this column and this column are the same thing, and this column and this column are the same thing. Okay, I'm working on something for my class right now, and I'll be right with you. So these are inverses because if I put an input into the function, like 6, the output for the function would be 18. If I take that and make it an input of the inverse, I wind up back at 6. And this is always true. So if you ever have to make a table of values for an inverse and you have a table of values for the function, all you basically do is swap the columns because the x-coordinates become y-coordinates and the y-coordinates become x-coordinates. The other thing you should know about inverse is that when you graph an inverse, so I'm going to graph these two functions. I'm going to graph one in red. I'll graph f of x in red. So I have -2, 0, and 0, 5. And I have 2, 10. Oh, I didn't graph that very well. I'm going to fix that. Sorry. So 0, 5 is here, 2, 10, 2, 4, 6, 8, 10, and then 4, 15, 11, 12, 13, 14, 15. And then that one point that doesn't really fall on the line because I decided not to make it all linear. 618. So that's my function. That's f of x. I could sort of connect those dots, but I'm not going to do that right now. And then if I graph the inverse, I have 0, -2, so that would be down here. And I have 5, 0, so that would be over here. And then I have 10, 2. And I have 15, 4. And 18, 6. And what I notice about these graphs, and this will always be true for inverses, is that they're a reflection of each other. That if I look at this red graph in the mirror, I see the green graph. And that's always true for inverses, that they're a reflection across this diagonal line, y equals x. So that's the other big property of inverses that you need to know. Property number 1 you need to know is that the x and the y coordinates get flipped. And property number 2 that you need to know is that they're reflections of each other. When you graph them, it's like folding that graph on the line y equals x, and the inverse and the function land on top of each other. Okay, those are the big ideas for section 10.7. That's a little pre-teaching for your lesson today. Good luck today.